What is fractography and how does it work? Have you ever wondered how engineers figure out why a product or component fails? One fascinating method they use is called fractography. This scientific study focuses on the fracture surfaces of materials. It helps us understand how and why something broke. By examining these surfaces, experts can identify the failure mode and mechanism behind the breakdown. Fractography starts with collecting the broken part. It is essential to prepare the fracture surface carefully. This means cleaning it and preserving its features. Any alteration could change the story the fracture tells. Once prepared, the surface is inspected visually, often using magnification tools. One common tool is the scanning electron microscope. This device provides detailed images at very high magnifications. When looking at the fracture surface, experts can see microscopic features. These features include fatigue striations, microvoids, and different types of cracks. Each of these characteristics can indicate specific failure modes. For example, a ductile fracture often shows rough surfaces with signs of plastic deformation. This suggests the material yielded before breaking. On the other hand, a brittle fracture has smooth, flat surfaces. This indicates a sudden failure without warning. Fatigue fractures are another interesting case. They display smooth areas that suggest crack growth over time. This happens under cyclic loading, which is when a material is subjected to repeated stress. By correlating these features with the material's properties and loading conditions, investigators can determine the cause of the failure. The typical process of fractographic failure analysis includes several steps. First, background information is gathered. Then, non-destructive testing is performed. This is followed by mechanical and chemical characterization. After that, both macroscopic and microscopic examinations of the fracture surface take place. Finally, investigators identify the failure mechanisms. Sometimes, simulation testing is conducted to confirm their hypotheses. This systematic approach helps reconstruct the failure event. It also guides improvements in design, material selection, or manufacturing processes. The goal is to prevent similar failures in the future. Fractography is widely used in various industries. Fields like aerospace, automotive, and manufacturing relying on it to improve product reliability and safety. By understanding how materials behave under stress, engineers can make better decisions. This ultimately leads to safer and more reliable products for everyone.